right, so if y equals 2, the domain is all real numbers. The range, well, the only y I have, range is y, is 2. So y equals 2. Or we could write 2, or we could write our little bracket 2, or we could write 2 like that, but it's just 2. Y equals negative 3. So on your paper, graph y equals negative 3 by yourself. And check it against what I'm getting. And then state your domain and range. Any questions? So constants. You know linear, you know absolute value, you now know constants. Let's look at step functions. Step functions are one of these little things. You'll see a step function, the greatest integer function in pre-cal. The only time we'll really address it much here is usually with word problems. So this is an older word problem. This is because your textbook is 10 years old, and that's where I stole it from. This is postage. So if you're going to the post office, this is the cost of mailing a letter. So my cost depends on the weight. So my y-axis is going to be cost. My x-axis is going to be the weight of the envelope. So up to 1 pound is 39 cents. Okay? So way back when, 39-cent stamps really existed. So now I buy the forever because I have no idea when the price changes on a stamp because I have my forever stamps. Before they started selling those, you'd have to buy 1-cent stamps to get whatever postage you had to the new rate. Anyway, so now you buy forever stamps. But this is a good example of like metering. If we were metering a package, it's based on the weight. So they literally lay it on the little machine, they figure out the weight, and that tells you how much postage you have to pay. Now, my graph, I want you to be able to read it from where you're sitting. So I'm going to kind of go out here and go maybe 1, 2, maybe I'll go by 2s. So here's 1, 2, 3, 4, 5. I'm just trying to enlarge it a little so you can see it. Now my y-axis is money. I have to get to $1.35. So I'm probably going to have to count by what? Well, let's see. 10, 20, 30, 40, 50, 60, 70, 80, 90, $1, 10. That won't work. What else? 20, 20, 40, 60, 80, $1. 20, 40, 60, 80, $2. I've labeled my axes. Now, I know that any weight that says weight not over. So what this means is anything that's greater than 0 but less than or equal to 1, not over 1. It can be 1, it just can't be bigger than 1. So this is what a step function looks like. Well, how much does a package weighing 0 ounces or 0 pounds cost? Nothing, because there isn't anything that weighs nothing, right? If it weighs nothing, I'm not mailing it, I don't have anything. So I know that if I'm paying for anything over 0 but less than or equal to 1 pound, it's going to be 39 cents, which is going to be awfully close to 40. So I have an open circle at 0, and I have a flat line all the way over to 1, because anything above 0 pounds, so 0.01 pounds is 39 cents. 0.02 pounds is 39 cents. So I do the open circle to say anything infinitely close to but not including 0. So this is a half a pound, a third of a pound, 2/3 of a pound, all the way up to a pound, I pay 39 cents. The second I go over a pound, 1.00000000001 pounds, I will now pay 63 cents. So I jump up, here's 60, so 63 is going to be slightly above that. Open circle, flat line all the way to 2. Anything greater than 1, less than or equal to 2 pounds is 63 cents. A weight not over 2 means anything greater than 1, less than or equal to 2. The reason I have open and closed circles is I can't pay both 60-something cents and 40-something cents for the same package. At 1 pound, I either pay 39 or I pay 63. I can't pay both. So at 1 pound, I pay 39 cents. It's a closed circle. At 1 pound, I don't pay 63 cents, but I'm really, really close, so I have to do my open circle. We're going back to, remember when we said x is greater than 2 on a number line? You did 2. Here's 3, here's 4. I had to do an open circle to show that it's anything greater than 2, even things infinitely close to 2. That's what I'm doing here. I have to get very close to that point. So anything right here where it's not equal to, these are open circles. So this would be an open circle. So you might want to write open circle to yourself. So if I have a less than or greater than, it's an open circle. Less than or equal to, greater than or equal to is a closed circle. All right, and we're just going to keep going. So anything over 2, over 2, but less than or equal to 3 is 87 cents. So over 2, here's 80, here's 90, close to 90. That would be 87 cents. Over 4 and up, or over 3 and up to 4 would be $1.11. And $1.35, that's 20/40. So $1.35 is up here. So that is a step function. What is the domain of this step function? Okay, so my domain are my x values. If I look at this graph, and I do my little highlighters that are under your desk, right? The lowest x value would be over here. On this graph, the highest x value is right here, because I've given you only data from 0 to 5. So my domain would be that x is greater than 0, less than or equal to 5. So from 0 to 5, including 5. Because I didn't have a package weighing $0, weighing 0 ounces or 0 pounds, because the package wouldn't exist. I'll take your answer either way. I'd like you to be able to get to interval notation, but if you give me a right answer in either form, I'll take it. All right, so if I take my y highlighter, my range is my lowest y value. Oh, wait a second, it's not continuous. My step function, my ranges are broken. So it's each one of those. So my range is going to be each one of these. So my range would be, in the fancy brackets like we do for discrete data, 39 cents, 63 cents, 87 cents, $1.11, and $1.35. And I use the curly little brackets anytime I have discrete data. It's called set notation. It's the set of all numbers that I've listed. So my step function, my domain and my range is usually going to jump. So I don't have an interval that I include. Questions? Let's do one more. We're going to graph one more, but first let's look at domain and range. This is the greatest integer function. So y equals the greatest integer of x. So we usually write it this way. And that just means I'm looking for the greatest whole number that is less than or equal to my x. So you'll study this in pre-cal, but like when x is 0, what's the greatest whole number less than or equal to 0? 0. All right, when x is 1/2, what's the greatest whole number less than or equal to 1/2? No, if x is 1/2, what's the greatest whole number less than or equal to 1/2? 0. No, less than or equal to. So when I have 3/4, what's the greatest whole number less than or equal to 3/4? So when I have 1, what's the greatest whole number less than or equal to 1? 1. So I have a flat line and an open circle. At 1, I jump up. I have a flat line and an open circle, and then I jump up. So this is my greatest integer function. Now, in pre-cal, pre-AP, you will take this function and you'll move him right and left and up and down and stretch and compress him. You'll do all your transformations to your greatest integer function. But what I want you to be responsible for is not graphing that, but telling me what's his domain. He keeps going forever in each direction. So if I know he keeps going forever, in the left direction I'm getting smaller and smaller, in the right direction I'm getting bigger and bigger, so my ends are there. But I need to look at what happens in between those end points. So if I read it from left to right, there's no breaks in my graph, because this x doesn't exist on this graph, but exists right here. And this x doesn't exist right here, but it does right here. And this x, I think I have a problem, but it's filled in right there. So all of my x's are included. So my domain is all real numbers. Now, what is my range? The graph keeps going on forever. So my range would be what? Can't be all real numbers because it's not 3.5. Like my range are my y values, right? So negative 4 is a range, negative 3 is a range, negative 2, but not negative 2.5. But it keeps going on forever. Ah, all whole numbers, or we could say all integers. You could write all whole numbers. Now the second graph, I'm going to tell you, is just a transformation of the first. All I'm doing on the second graph I gave you is I'm picking the graph up and I'm moving it to the right one space. So literally this piece of the graph, I move over 1 and it becomes this part of the graph. This guy right here, I'm moving him to the right one. So instead of being between 1 and 2, he's now between 2 and 3. So all I did was shift the whole graph to the right. So you don't need to know this, but it's a shift to the right inside my greatest integer function. So if I tell you that, if I tell you these two are related, all this guy did was shift to the right. I give you the equations. Well, if my domain was everything and I shift everything to the right, what's my domain now? Everything. Everything doesn't change. And what about my range? It's still the same thing. It's all integers. So if I move a graph left and right, that typically changes my domain. If I move it up and down, that changes my range. If my domain was everything and I move it right or left, it's still everything. Infinity moved to the right is still infinite. Okay, we're going to graph one more step function. This will make me rethink my profession right here. One psychologist charges $85 an hour for counseling, and the way the contract reads, it's $85 per hour or any fraction thereof, meaning any fraction of an hour gets charged as the next hour. So half an hour, she charges you for an hour. 3/4 of an hour, you pay an hour. An hour, you pay an hour. An hour and 5 minutes, you pay 2 hours. Because you are in a fraction of the second hour. So any fraction of the hour gets billed for the whole hour. That's what we mean by any fraction thereof. So your bill depends on what? Your time, how long you're there. Now, I'm going to enlarge this again so we can all see. So I'm going to go 1, 2, 3. Here's 1, 2, 3, 4, 5. And I know she's going to charge me for the first hour how much? 85. I'm going to enlarge this side too. 2, 3, 4. There's 85. But for the second hour, what am I paying? What do I pay every time? 85 and 85 is 170. And then if I tack another 85 on, I'm at 255. And another 85 on, I'm at 340. And another 85 on, I'm at 240 or 425. I just gave myself some space. You just have to be consistent. I did 4. All right, so we're going to graph this. So if I go in and I'm there 0 hours, I pay $0. Okay, that makes sense. There's my point. If I'm there 1 hour, I pay $85. So we're good. However, she said any fraction thereof. So half an hour, I pay $85. So any fraction of my hour, I pay the full hour. So at half an hour, I'm at 85. And at 3/4 of an hour and 1/4 of an hour, all the way up to, but not including 0 hours, because obviously 0 hours I pay $0 for. Now, as soon as I go over 1 hour, so like 1 hour and 2 minutes, I'm now paying $170. So how do I show that? 1 hour and 0 or 10 or 5 minutes. What I do is I do an open circle here, and I say anything close to 1 up to and including 2. Anything over 2 up to and including 3 would be billed at 3 hours. Anything over 3, I'm into the 4th hour, up to and including 4. Anything over the 4th hour, up to the 5th hour, I'm including 5. So So there's my step function. Now, I've had an argument made for the fact that if you're not going to a psychologist, this point doesn't matter, and I can go with that. Like, obviously, 0 hours is $0. That's fine with me. Okay? If you don't want to graph that point, we can make an argument either way. Given the graph without that point, what's the domain? Domain are my x's. Read your graph from left to right. What x's are on my graph? No, not just 1, 2, 3, 4, 5. A half, a third, a fourth, an eighth. So any x that is greater than x is time. It can't be less than 0. So x is greater than 0, or we'd say 0 to infinity. Now, the range are my y values. What's the range? What? All right. So I could either list them 85, 70, 220, or whatever, 255, 340, 425. If I want to keep going, how can I write that? No. No, because how about multiples of 85? There is no x in it. Because if I did 85 times x, when x is half, I'd only be paying half of that hour. I pay the whole hour. So it's not a y equals mx plus b. It's a step function. So multiples of 85. All right. On the very back of your notes, real quick, while I am saving this recording real fast, there are 4 graphs. I think it's like example 10. These 4 graphs, all I want you to do is write either piecewise, absolute value, constant, or step function, what you think they are. We'll come back to this in a minute. So it's on the back of your notes, the very back page of your notes.